All right. I'm going to demonstrate a Labview project. It's a function generator and an oscilloscope. So let's get started here. Down here, I just took a photo of an old function generator, duplicated it, so now I have two function generators here, and overlaid the knobs with Labview knobs, transparent. So here you have your frequency area of the function generator, and this is for your fine-tuning frequency. You have a multiplier down here that multiplies it by 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, and I didn't go higher than that because I didn't want to increase the sampling rate too much on the oscilloscope. Because it takes resources. Here you can adjust the phase, 0 to 360. I put the noise addition here just because there was no other place really to put it. So you can choose between off, uniform, or Gaussian noise, and a noise amplitude here. What else? A voltage offset. I'll set that at 0. It helps if you have a small knob like this to extend your mouse farther away from the knob for more fine control. Here's just the amplitude. I just chose to use 0 to 15, and that would give you 30 volts peak to peak. This button here changes the function, which is displayed here. So sine, square, triangle, and saw, and then back to sine. And everything applies to this other side as well. So I'll go ahead and turn on one of the channels on this function generator, and you can see I have volts per division, so as that decreases, the signal is going to be zooming in. And each of these divisions is represented by this measurement. So this is 3.5 volts from the top to bottom of this box, and then as you decrease that, it's now 2 volts from the top to the bottom of this. And I just used the grid that's included in this photo. And you can see if I change the signal, it turns into a square signal. Here's our seconds per division. Zoom in or out with respect to time. So if you take the position here and line up with one of these lines, you can see if you start here, one cycle is probably, and so you just take 2.9 and multiply it by your 19 milliseconds. And you get that number, 55 millisecond period, which is a 18 hertz, I guess. So, and that is about what we have over here. So, give or take, it's hard to eyeball it. That's why you have the channel measurements. So if you click on this, it'll give you the max, min, voltage peak to peak, RMS. So our voltage peak to peak is 14.8, which makes sense if the amplitude is 7 volts. Min and max are close. I tried to get the offset close to 0. And the RMS voltage is 7.04 volts. If I had this second channel on here. We'll see what happened to be on this one. And of course, the time seconds per division apply to both signals. So I only have 1 seconds per division knob. You can see how one compares to the other. But of course, you're going to want to just be able to click on the measure and go to amplitude, frequency, and look at the signals from that perspective. So these buttons work voltage, frequency, and then off. If you have one of them on and then turn off the channel, the measurements turn off with it. Channel comes on, they come back on. Intensity of the beams can be adjusted to be thicker or thinner. So the frequency area kind of lacks in function, just shows both channels all the time, versus what I thought would be the maximum frequency I'd be using. So I didn't add a whole lot of functionality to it, but I'll just show that it's measuring the frequency here. That's channel 2. And then channel 1 obviously is the square wave. You see all those harmonics. So that's it on the frequency. I also have the ability to add a cursor to channel 1 that displays the time at a point and the voltage. But it only applies to channel 1. The channel 2 cursor, as it turns out, can't be accessed because channel 1 and 2 are actually overlaid on top of each other, and so I can't get to the second cursor. That demonstrates it. That's I'll throw on the noise. So we'll go back to a sine wave on this one, and we'll turn off channel 2, and we'll turn off the cursor. Turn up the frequency a little bit. Have it set at a fixed interval, no triggering. So this is uniform noise right here. You can see I can adjust the amplitude on it, and then Gaussian looks non-uniform. Okay, that's it, and power button. Thanks.